Well, hello, everyone. Welcome to our first pre-calc lesson, long distance style. It's going to be super fun. We're going to take notes on section 15.4 today because before we left, we had done sections 1, 2, and 3. So you're going to find your note packet. And the note packet, you're going to find the one that says section 4, this guy right here. And you're just going to fill in the notes. You probably need to have your scientific calculator with you also. So if you can finagle where that baby is, go ahead and get that really fast. And let's get started. So while you're looking for your calculator, I'm going to switch on over to do the PowerPoint. Just give me just a second. And this is going to be super great. Okay, so today we are definitely doing this section called measures of variability. So this whole time, right, we've been talking about data. We've talked about how to organize data. We've talked about how to find like averages and measures of central tendency, mean, median, mode, all that good jazz. We talked about how to draw different representations. So we've done stem and leaf and different distributions and histograms and so many great things. So now we're going to talk about how much the data varies, okay, as opposed to like how much it's the same. So you're filling in some of these things. It says knowing averages about a data can be helpful, but sometimes we want to know how it varies, just like I just said. So measures of variability are, there's two of them that we're going to talk about, and it's range and standard deviation. So I want you to write both of those things on your notes, range and standard deviation. And what range is probably the easiest thing. It's just, and actually in my classes, we've been already saying what the range is. So I think intuitively you already know what the range is. Range is going to be the difference between the smallest and the largest values of a set of data. And so literally you're just going to be subtracting the largest, subtract the first, and it's going to be that simple. So we're going to jump right into example number 1. And it says some professional rodeos in the US from 1980 to 1988, and they've listed those. And then it says, what's the range? So basically I'm literally just going to be like scanning the data, scan, find the highest and find the lowest. Okay, the highest one is 707, the lowest one is 616. I take those values and subtract them. I also use calculator. And I get that 91. So the range of values is 91, okay? The mean of the set of data, which I did not ask you to find, and it's not actually in the question, but I would like you to write it down. The mean is 642.8. When I took all of these values, I added them up and then divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 9. It's 642.8. And then what does that mean to us, right? So like, what does having a mean of 642 with a range of 91 tell us about the data? Maybe we would write down that, sorry, I clicked too many things. Maybe that would mean that since the numbers are kind of big, but the range is small, that kind of all the numbers are sort of like close to each other. So I wrote down, since this is just me, since the range is small compared to the mean, we can conclude that most of the data is relatively close to the mean, right? If we had said, let's pretend the mean was still 642.8, and then the range was like, 500. Whoa, then you would say to yourself, wow, that data is really spread out, right? Like it's spread out, and it's not very compact. And I feel like right now our data is pretty compact to each other. So before we would move on to the next thing, we're going to do a stand and talk. So let's try to be creative with our stand and talk. Maybe you're saying to yourself, no one else is in my house. You can have a stand and talk with yourself or your dog or, just the air. That's totally fine. If you want to like FaceTime somebody, that's really cool too. So basically what I want you to do is just take a moment, like actually do this, guys. Pause the video as soon as I show the picture up here and just have a moment to think about what it's asking, whether you're actually discussing it with somebody or not. And, maybe stand up. That could be great. So here's the picture. The question is, what is the same and what is different? So go ahead and pause the video now. Do something to do with this stand and talk, and then we'll get right back to each other. So pause now. Okay, you're back. So hopefully you did your stand and talk and you thought about what the data was. I was thinking to myself that maybe on data set A, I might have said that what's different about this is there's like a lot of repeating numbers in data set A and data set B and data set C. I see none of the data repeats. When I look at the numbers though from data set A, B, and C, the range on all three of them, I don't know if you guys saw this or not, but the range was 100 on all of them. Data set A, it's 100 minus 0. Data set B is 125 minus 25 is 100. And the same thing for data set C. If you look at data set B, only the two extremes are different. Everything else is 75. In data set A, there's only two numbers, zeros and 100s. And then data set C is kind of all over the place. So maybe you said some of those things. So what we're going to do now is go back to our notes, right? Since we just did our stand and talk, hypothetically, and we're going to write some fun things. So we're going to describe the distribution of the data. So you may write something like for this data, something like we did in the stand and talk, that it's just the two extremes and there's nothing that's close to the mean. What the mean is on that one, there's 1, 2, 3, 4, 5, 6, 7, 8 terms. So like 600 divided by 8. My calculator's not working very much right now. Sorry. User error is 75. You know what I actually think, guys? The mean for all of the data is 75, every single one of them. So on this one, there's no points where the mean is actually in the data set, just the two extreme values. For part B of the data, it's kind of like the opposite. There are two extremes and then everything else is the mean. That's kind of interesting. So that's what I wrote down in that little box. Most of the data is at the mean. And then there's just the two extra like extreme values. And then for part C, I wrote down that the values are kind of like spread out evenly all the way from 25 to 125. They're just spread out. In fact, if I actually kind of scan that data, it looks like they're all about 15 apart from each other, which is kind of interesting. So the thing is that if I said to you, I want to see if I can write on this PowerPoint right now. Okay. If I said to you, hey guys, I have this data set and it has 8 items. Right? I said the mean is 75 and the range is 100. Do you actually know what that data looks like? And the answer is no. All three of these sets, okay, all three of these sets have the same information that's listed up here in this, in the prompt. But as you can tell, these are very, very, very different data sets. They're all different. So what that brings to mind is that maybe, just maybe, we need something else to describe our data, right? If we were showing what the data looked like, then maybe that would have been like the histogram would look different or the frequency polygon would look different. But is there like another way? And the answer is totally yes, okay? So on your note packet, there's a little asterisk. I want you to write down that you can have lots of variation in data that has the same mean and the same range, basically what we were just discussing. Well, I was discussing. So finding, quote, the variability of the data set is needed. So you're writing that also on your note packet. Finding the variability of a data set is needed. And the way that we find this variability is something called standard deviation. So standard deviation is what we're going to work on finding now. So you're going to write that down. I think I was moving kind of fast. I'll pause just for a second so you guys have a moment to write that stuff down. And then we will turn the page in our note packet. And we will talk about how does one find the standard deviation, okay? The symbol for standard deviation is this lowercase sigma, okay? There is a capital sigma that maybe you remember last year. Capital sigma looks like this. Well, kind of like that. That's bad drawing. But it kind of looks like that. This is what's called a lowercase sigma. So it looks like almost like an O with a little hat on it, or like really nice boy band haircut or something on this little O. So this is called a sigma. Usually when I draw it, I just kind of draw like an O with a little tail on top. There is another way to write this. Oh, no, just kidding. Not another way to write it. The way, scratch that. What I want you to do is on the line next to it, I want you to write that X bar. That is actually how you read that. X with the line on top is X bar is what we call the mean. Okay. So in this table, you don't have to make a table, but I think it's really nice to organize it in a table just because sometimes it gets tricky with your stuff. So in our table, we in fact, in this column right here, we're going to write down just whatever the value that we're talking about, like the data is. We're going to find the mean value. We're going to find the mean right here, and we're going to take the value of each data point, subtract the mean listed here, and then we're going to square the ones from this column right here. In this column right here, we're just going to put the squared versions, okay? So let's go ahead and do all those things. So this will be your x value, so you can write that down, x value. This is going to be the x value, subtract the mean. And then this one is where we're going to square that difference that was in that previous column. So we're just going to square the difference. Then what's going to happen is you're going to get a list of numbers. So this is all right here, going to have a big old list of numbers, okay? And then what you're going to do is you're going to sum those. So you're going to add that list up. You're going to add it up. You're going to get a total. With that total, you're going to divide by the number of x values, right? It's almost like you're finding the average. So you're going to divide by however many terms there are and write that to the side over here. And then what you're going to do is you're going to take the square root of that number. Okay? The square root of that number that's been added up and then divided by how many terms there were. Okay? This answer right here is your standard deviation. Okay, so this answer right here, if you guys want to put like a big circle around this guy right here, I just like scribbling. That right there is your standard deviation. And then the variance is another fun thing. Variance is sigma squared. Okay, so this guy right here, this answer right here, this is sigma. Okay, this answer right here, before you square it, this is sigma squared. This is the variance. So they're both found when you do the calculations. Are both found in the list. Okay. A couple of fun little asterisks here, little notes. When you find the standard deviation of an entire population, you know all the data for everything. You divide by n to get this spot right here. Okay, this is the spot, and you divide by n to get this spot. If you know every single data point. Now, if you're going to do a sample set, which in real life is actually more applicable, okay? And in stats class, if you happen to go into stats class next, you will definitely not be using entire populations. You will always be using a sample set, okay? So if you're going to use a sample set, you're going to divide by n minus 1. So however many terms there are, say like there was, a sample set of 10 terms, okay, or 10 data points, then you would divide by 9, okay, not divide by 10. And then what they do is they don't call it sigma, they call it S instead. When you do your homework, I'm going to ask you to calculate both ways, one time with the S and one time with the sigma. So we're almost done with our notes. Let's go ahead and just do an example of this, okay? So this is going to be, we're going to consider the entire data set, okay? We'll do a sample set in just a moment, but we're going to consider this the entire data set. And it says, find the standard deviation and the variance for number of accidents reported in a year by drivers with suspended license. Seriously, why are they even driving? I don't know. Okay, but anyway, we're gonna figure this out. So what is the average? So on your notes, there's a box for us to figure out the average. You will take your calculator. Go ahead and do this with me. We're going to add 2 plus 5, 3, 7, 2, 6, 1, 1 and 2. Put enter, and then I'm going to divide by 8. And I get 3.5 is my average, my mean. That's what X bar is. So now that I know what the mean is, I'm going to go ahead and fill in my chart. So in my chart, in this column right here, I'm going to erase this, okay? But in this column, I'm going to list all my numbers. Probably what I would do would be smart to list them in number order, like 1, 2, 2. 2, there's 3 2s. 3, like just go ahead and list it on down, and then we'll organize our data. So here we go. So that's what I'm going to do first. I'm going to put all the X values in. Where did I get these X values from? Right there. That's my data set. And so I have all of my X values, and then I'm going to start subtracting the X value subtracted the mean. So I'm going to go 1 minus 3.5. 1 minus 3.5 is negative 2.5. Okay, 2 minus 3.5 is negative 1.5. Sorry, I forgot I was squaring them first. I'm going to put in my calculator already, 2.5 squared or negative 2.5 squared, and I get 6.25. Then I'm going to go to the number 2 value. And so if I go 2 minus 3.5 for the mean, it's negative 1.5. I square it, and I get 2.25. Those values are repeated for the other two 2's. Then I'm going to go 3 minus 3.5, which is just negative 0.5. I square that, and I get 0.25. 5 minus 3.5 is 1.5. 1.5 squared, 2.25. 6 minus 3.5 is 2.5 squared, 6.25. 7 minus 3.5 is 3.5. 3.5 squared is 12.25. Okay, so now the instructions were to go ahead and add up that column. So I'm going to add that column. So I add all those values up, and I get, tap, tap, tap in your calculator, 34. Okay, so 34, great, I'm on my way. Next, what I'm going to do is I'm going to divide by how many values there were. There was 1, 2, 3, 4, 5, 6, 7, 8 values. So I'm going to take my 34 and I'm going to divide it by 8, and I get 4.25. Folks, that is the variance. I have already identified the variance. Okay, so the variance, there's that answer, done. And now I'm going to take the square root of that, and the square root of 4.25, just go ahead and rounding to the nearest hundredth is 2.06. And those are your two answers. Okay, let's go ahead and just do this question with pretending that this was a sample set instead of a population. And so if we treat the data as a sample instead, everything would be the same except for this spot right here. At this spot right here, we would not have divided by 8. We would have divided by 7. So I'll pick up with that 34, divide by 7. That gives me about 4.86, which would be the variance. And the square root of that would be about 2.20. And that would be my standard deviation represented by S instead of lowercase sigma. That's it, guys. We're running some numbers. Okay. So this is your homework assignment. Of course, I also posted it in Google Classroom. Please note this part right here. Okay. So this part right here says that when you're doing the standard deviation and calculating it for numbers 12, 22, and 43, go ahead and find the sigma using the entire population, and then S using the sample set while you divide by 1 less than what there is, and then you'll be golden. Okay, let me go ahead and stop sharing this. I know you guys can see all that. That's all good. Okay, so we are now going to just check back in. Hope that was a great lesson, you guys. Okay, so remember what you're going to do is you're going to do the homework. You are going to, once you get it finished, you're going to take a picture of it, post it online. I'm checking it off just to make sure you'll have until tomorrow to get it done. And I think that's it. So have fun. Hope you're staying safe. Love you. Miss you. Bye.